This work focuses on developing an efficient pipeline for tool segmentation in endoscopic videos in the wild. The problem of tool segmentation in endoscopic images presents several challenges. We focus on two significant ones in this work. The first challenge is processing endoscopic images in the wild, meaning complete endoscopic videos acquired during real medical practice in which many frames don't actually contain tools. Therefore, when the segmentation model is applied, it introduces false positives. The second challenge is enabling the use of the segmentation model in real time, which is essential when the segmentation is part of a downstream task with computational restrictions. The models used in this paper are evaluated on 3 endoscopic tool segmentation datasets. The first dataset, EndoV17, is a publicly available dataset developed for the 2017 Robotic Instrument Segmentation Challenge. It consists of frames from several porcine endoscopic procedures which all contain tools. The second dataset, Cavaser Instrument, consists of frames obtained during several gastroscopy procedures which always contain tools. The third dataset, HCULB, is made of frames from various colonoscopy procedures recorded during medical practices within the Endomapper projects. It contains frames both with and without tools and can be divided into 2 sub-datasets, HCULB tools with frames with tools, and HCULB full with frames with and without tools. Here are some frames from the HCULB full sub-dataset. Our first contribution is the evaluation of a general-purpose segmentation model, MiniNet, on endoscopic data. Medical images present specific characteristics, meaning general-purpose models have to be adapted to this type of images through fine-tuning. Additionally, if we want to use the segmentation model in real time, it needs to be efficient. An example of an efficient model is MiniNet. MiniNet has not yet been tested on medical datasets, but achieves similar or better results than state-of-the-art efficient models on non-medical datasets. Its detailed architecture can be seen in the figure below. We first evaluate MiniNet for binary segmentation on the 3 datasets. MiniNet achieves similar mean intersection over union values as state-of-the-art models, but is more efficient, meaning it has a much smaller number of parameters with faster inference time. The segmentations obtained on different frames further show that MiniNet is comparable to state-of-the-art models. They also show in the third column that all models introduce false positives when there are no tools present in the frame. We further evaluate MiniNet for multi-class segmentation using the EndoV17 dataset. In this case, MiniNet obtains better results than state-of-the-art models while still being the most efficient. Here are some examples of multi-class segmentations obtained using MiniNet. Our second contribution is to develop a module to efficiently remove false positives. As previously shown, all models studied in this paper introduce false positives when used on images without tools. We develop a binary frame classification module to classify frames with and without tools. Our proposed pipeline takes as input the image that we want to segment. The MiniNet encoder is then applied. The features extracted are then passed to our classification module, which consists of 3 simple layers, pooling, dropout, indents. The output is a binary label, which determines if the image contains a tool or not. Based on that label, if there is a tool, the MiniNet decoder is applied to the features previously extracted, and a segmentation mask is returned. If there isn't, no segmentation is computed, and the black mask is returned. Our binary classifier is trained and evaluated on HCULB full dataset. Using the best 2 segmentation models, MiniNet and MFTAPNet, it first appears that in general, MiniNet introduces less false positives. It also appears that our pre-filtering classifier reduces even more the effect of the false positives, reaching a higher mean intersection of a union with both models. The following video shows sequences from the HCULB full dataset segmented using MiniNet. This video shows that fine-tuning the model on the specific dataset makes the segmentation obtained better. We can also see some of the false positives introduced by the model that the classifier manages to remove. To conclude, we have shown that MiniNet obtains comparable results to state-of-the-art on 3 endoscopic datasets while being more efficient in terms of memory and inference time. Our contribution is a simple pipeline which includes MiniNet and adds a classification module to limit the effect of the false positives possibly introduced by MiniNet while still being efficient.